In this video, we are going to talk about gases. Now, it's very important that we understand gases in forensic chemistry because a lot of explosions deal with the production of gases. So, an explosion is where you have a chemical reaction that produces a an extremely large amount of energy and gas at the same time. And when that happens, if that gas is flammable, then you can light that gas on fire due to the amount of energy that is formed. Here are a whole lot of different explosives. I want you to pay attention to the fact that every single one of them has a nitrogen bonded to an oxygen. That is very important in the chemistry of explosions. Now we have two different types of explosions. A low explosive, where you is one where you have to have it in a container. If it's not in a confined container, then it won't produce an explosion. And the detonation is by flame ignition. A high explosive does not need to be confined. And so detonation can be by heat or a shock wave. They can be a lot more volatile, if you will, because of the fact that you can have them just anywhere. Here is the detonation of nitroglycerin. So nitroglycerin is an explosive and it produces carbon dioxide, water, nitrogen gas, and oxygen gas. And we already know that oxygen gas is flammable because we've seen this in combustion reactions. It is necessary for combustion reactions. So, in order for an explosive to work, it needs to have two things. It needs to have a fuel source. So, this is going to be carbon or hydrogen. Essentially, it has to have something that will burn. And then it also needs an oxygen source. And this is where we have our NO2 groups. So the NO2 groups is what's going to provide oxygen for the explosion. When we're talking about the oxygen balance, we have either a neutral, negative, or positive. So a neutral oxygen balance is where you have enough oxygen to completely oxidize the carbon and hydrogen. So if you're thinking about this in terms of a chemical reaction, this is where your multiple ratio comes into perfect play. I have the exact amount of oxygen that I need to completely oxidize the carbon and the hydrogen atoms. Now, a negative oxygen balance is where you don't have enough oxygen to completely oxidize the carbon and oxygen. Or sorry, lo siento, the carbon and hydrogen. And then finally, if you have a positive oxygen balance, then that means you have extra oxygen. So another way to think about this is in a neutral oxygen balance, you don't have a limiting reactant. You have the perfect amount of oxygen. to the perfect amount of carbon and hydrogen. In the negative balance, then the oxygen would be the limiting reactant, if you will. In a positive balance, then the other thing would be the limiting reactant. You have a surplus of oxygen. Now, oxygen is a gas, and you'll notice that the detonation of nitroglycerin right here, nitroglycerin is a liquid, but the reaction only forms gases. So it's very important that we have a good understanding of gases. So let's talk about the kinetic molecular theory of gases. So gas molecules are moving very, very, very fast. They are small and they can be very far apart. So if you recall, gas particles fill whatever container they are in. But on top of that, they are compressible. So they can be compressed easily. So since they're so far apart and really small, it's really easy to make them get closer together. And that is what being compressed is. The second thing in the kinetic molecular theory of gases is that gas particles lack intermolecular forces. Another way of saying that is that gas particles, or gas molecules, if you will, are not attracted to each other. The third postulate is that gas particles are going to move in a straight line and they will collide with each other randomly, and they will also collide with the container. So these collisions with the container walls create the pressure. So you can think of pressure as how often and how with how much energy the gas particles collide with the side of the container. Now, the average kinetic energy of the gas particles is going to be proportional to the temperature. So what that means is if I increase my temperature, then I'm going to increase my energy. And that makes sense because if we increase our temperature, that makes our gas particles move a lot faster. In terms of explosions, we have two possible limits. So we have the lower explosive limit, and this is given the abbreviation LEL. So if you are below LEL, then the explosions just won't happen. There's just not enough fuel present. If you are at the upper explosive limit, or the UEL, then explosions will still not occur. We don't have enough oxygen present. So you have to be at a very specific ratio with fuel and oxygen in order for an explosive to happen.